Every day, thousands of buildings are built, and somewhere in that reinforced concrete structure, there are seemingly lifeless steel bars. But in reality, behind each steel bar is a complex, precise, and arguably artistic process. In this video, I will introduce you to a factory in Japan, where concrete reinforcement bars are mass-produced with precision down to the millimeter. We not only watch the process, but also together exploit and evaluate the good points and hidden values in each stage. The journey begins with what most of us think of as trash, scrap steel. But in the eyes of the Japanese, it is a circular resource. After being carefully sorted, removing impurities and non-ferrous materials, the remaining steel is fed into an electric arc furnace. Here, using powerful electrical energy, temperatures of up to 1,600 degrees melt and regenerate the steel. Recycling scrap steel in this way reduces CO2 emissions by 60 to 70% compared to smelting from virgin ore. And it is worth mentioning that the dust filtration and emission control systems here are extremely strict. Japanese environmental standards do not allow for any leniency. Why do you think this method is not more widely used in developing countries? Once the steel is in liquid form and the chemical composition meets the standards, it will be continuously cast into steel billets. These billets are usually square or round, more than 10 meters long, and weigh a ton. Next is hot rolling, the stage that determines the final shape and size of the steel bar. The billets are reheated, then passed through a system of giant rollers, gradually pressed down to the standard size. Noteworthy point: each roller in the rolling line is machined extremely precisely. The smallest error can cause the steel bar to not meet JIS standards, which is considered one of the most stringent standards in the world. This process does not only rely on machinery, but also on meticulous calculations by engineers. How hot? What is the rolling speed? All directly affect the mechanical properties of the finished steel. Steel for concrete cannot be smooth, otherwise it would slip in the concrete when the structure is loaded. So after rolling, the steel goes through a rib-forming machine. These ribs are rolled on the surface in the correct shape, spacing, and depth. And here's the interesting part. The factory uses industrial cameras and laser sensors to inspect each steel bar on the line. If there is a defect, even the smallest one, the machine automatically removes it from the line. They don't just do visual inspection, they also do physical inspection, tensile testing, bending testing, measuring yield strength and elongation. Every batch of steel has to go through the test. That's why Japanese steel is popular in both the US and Europe. Are you confident in the quality of the steel you're using for your home? Are they tested as rigorously as this? After forming, the red-hot steel bars are cooled with circulating cold water. This is not only to cool down, but also to control the microstructure of the steel, thereby improving hardness and ductility. Finally, the seemingly small but extremely important step, bundling and labeling for traceability. Each bundle of steel has a QR code containing full information about the source of raw materials, production date, inspection results. Traceability management like this makes any errors, if any, traceable. A clear chain of responsibility is the foundation for sustainable quality. We have just completed a cycle of reinforced concrete production, from waste to resources, from scrap steel to modern building materials. In Japan, steel production is not just an industry. It is a combination of technology, environmental responsibility, and quality culture. For me, the most impressive thing is not the modern machinery, but the thinking behind it. The thinking of making products that not only meet, but exceed standards. So in your opinion, which steel is worthy of being used in your construction project? If you find this process as impressive as I do, leave a comment. Do you think this technology can be applied in our country? Don't forget to follow the channel to discover more cutting-edge production processes through the perspective of an engineer like me.